Everyone, this is your note 6, lesson 6 from unit 5. This is our last note before the test. So we're going to practice a few things first, and we'll do a quiz before the spring break, and then we'll do a review after the spring break, and then a test. I guess we'll have to do it that way. So this is about permutations and combinations. So what are permutations and combinations? So these things are special in math, and we're going to learn about both of them. But before we start, let's start with something called the fundamental counting principle. You guys know how to count? You think you do, huh? Well, this is something special for that. So without further ado, so in this lesson, you should be able to compute the number of ordered and non-ordered arrangements or outcomes of using permutations and combinations. So let's get there. We're not there yet. Okay. Basic counting principle says that if you have A possible outcomes for one event and B possible outcomes for another event, you get the number of total outcomes for both events by multiplying A times B. So I always use the ice cream. So if you had like chocolate, vanilla, strawberry, and you had 3 different sizes of cones, and you had 1 scoop or 2 scoops, you could make lots of different combinations of ice creams there. Okay, so that's how would we count how many different kinds of ice creams we could have? Well, if you had 3 different size cones, 3 different 1, 2, or 3 scoops, let's say, and say 4 flavors: chocolate, vanilla, strawberry, and mint. That means you'd have 3 times 3 times 4, 36 different possible ice creams, like with different sizes. You could have a small strawberry with a sugar cone, or a large mint with a different kind of cone, right? Plain cone. So there's 36 different possibilities right there. Okay, so let's start with this. A couple plans on having 4 kids. Oh, they're crazy. How many different girl-boy outcomes could there be? So the first birth, the second birth, the third birth, the fourth birth. So as we look at it, we might think, well, there's 4 different births. Let's see, it could be girl, 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 girl. Whoops. Girl, 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 boy. We could list them out like this, right? And we'd have like a bunch of them. But we always risk when we do this that we might like forget one of the combinations, even though you might start out girl, 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 boy, girl, girl, boy, girl, girl, boy, girl, girl, and then start with the first one as a boy. You could like have some system where you start with all boys and put the last one as a girl, and then you could like have the second to last one as a girl, then the third to last one, and then the very first one as a girl. So then you have 2 girls, 2 boys, girl, boy, and then you have the 2 girls on the outside, the 2 boys on the inside. Then you have boy, boy, girl, girl, because you did girl, girl, boy, boy. You can get boy, boy, girl, girl. So you could get these, and you would count them up, and you'd get 16 total outcomes or possibilities for the way that a couple could have 4 babies, right? Right. You might also find an easier way to do that if you can think of it. And especially if you have a lot of outcomes, you could say that there are 2 outcomes for each child, girl or boy, and then they're doing it 4 times. So it's 2 times 2 times 2 times 2, 4 different numbers of times, right? So this is 1, 2, 3, 4 of those 2's together, right? Don't say 2 times 4. That would be wrong. That would give you a smaller number than you really need. You actually could write it like this, because we like to write it 2 to the power of 4, right? And that's your 16, that's equal to 16, right? Okay? How about if you have a test and you could answer it always, sometimes, or never on the calculus test? There are 8 questions. How many different ways can you answer the quiz altogether, like totally different answers, if you completely guessed everything? how many different possibilities are there? Well, there's 3 possibilities for the first answer, 3 possibilities for the second answer. You could list them all out, and you'd be like, oh, wait a minute, this is getting way too big, because all of them could be always, 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 always for the 8 answers. And then you're like, always, 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 sometimes. And you're like, wait a minute, there's going to be way too many. So you would use the fundamental counting principle to say, well, there's 3 possible outcomes, always, sometimes, never, for each question, and there ends up being 8 different questions. So 3 to the power 8 is how you'd count the total number of outcomes. Okay? 31 different sandwich options at McDonald's. Yeah, are there really? Not including breakfast. For each of those 31 sandwich options, you have 3 different sizes of fries that you could order. And then you have, for each of those sandwich options with those fries, you would have 3 different size drinks that you could order. What's the total number of meals that you could get? I think it's 200 and something. 279. Very good. Excellent. That was what we finished on Friday. The rest of this comes down to permutations and combinations. We'll do it in a separate video.